Welcome back to my Mr. B's math class. Today we're looking at the last concept in this unit, which is 3.5, applying the Pythagorean relationship. So your student outcomes for today are 1, I can apply the Pythagorean relationship to solve problems, and 2, I can determine distances between objects. Now, we'll get into that right away. So before we start anything, let's just go over a quick review of the most important part of this unit. We need to remember that this formula, a squared plus b squared equals c squared. Or the other one we're looking at is, if we're looking for that leg of a triangle, we're going to look at our formula as c squared equals a squared minus b squared. And just keep in mind, the first one, that's when we're solving for c. If we don't know c, that's what we're solving. The second one means we know c, maybe we know a, but we don't know b, or vice versa. Maybe you know b, but don't know a. Okay, but that's what we got to keep in mind. So today's actually going to focus more on problem solving. It's just taking what you've learned from this unit, using these formulas, and applying it to a problem-solving question. So let's take a look at our first example. So our problem-solving example says, Brady and Jack are canoeing on a lake. Now that's our first problem. Actual problem is, there are 2 boats ramps on the lake. How far is the between boat ramps? Well, as you can see from my lovely diagram here, okay, we've got boat ramp 1 right here. And actually, I'll just help you out by drawing a little, circles we know. And boat ramp 2 is down there, obviously. Okay, we know that distance from here to here is 1,500 meters. Distance from here to here is 800. What I want to know is how far is it diagonally across. Instead of having to make them drive a boat over here to this boat launch, how far is it just to go across? And we have a lovely little diagram of Brady and Jack right here. So to solve this problem, really, when you look at it, you can see right away it's just a triangle problem, right? We've got our A, our B, and right across from that right angle, we've got our C. We know what A is, we know what B is, but we don't know this distance of C. So what are we going to do? We're going to follow our formula. So our formula before was A squared plus B squared equals C squared. We're going to fill in for what we know. Well, we know A is going to be 800. I'll make my brackets here. 800 meters squared. Plus, we know our B is 1,500 meters squared, so plus 1,500 meters squared. And we don't know C over here, so equals C squared. Now we need to do the work, so we need to make sure we're doing 800 times 800 because that's what square means. So 800 times 800 is going to give us 640,000 meters squared plus 1,500 or 1,500 times itself is going to give us 2,250,000. Meters squared equals C squared. Now we need to add them all together. So when we add 640,000 with 2,250,000, we're going to get a big, big number, which is actually going to be 2,890,000 meters squared equals C squared. Now we're looking for our side length, because right now we've figured out what that square attached to that side is. To find our side length, we need to make sure that we square root both sides. And remember, when we square root, that cancels out our squares. So when we root that number, we're going to get an answer of 1,700 meters equals C. So that's our final answer for this one. So you can see you've taken a problem-solving question here. You look at your diagram, interpreted it, and created your solution. Just remember, guys, if it's got the diagram here with it, just think of it as any other right triangle Pythagorean question and just use what you know, right? Use your A squared plus B squared is C squared. Let's try another one. Connor walks across a rectangular field in a diagonal line. Michael walks around the 2 sides of the field. They meet at the same corners, which we've got right here. Who walked further? Well, we can see Connor went across this way, Michael went this way. So we got to ask ourselves who went further. So you can pause it here and give it a shot. You can see that The entire length of the bottom of the rectangle here is 300, and this distance that nobody walked here is 120 meters. So give it a pause and then play when you're ready to watch the solution. Okay, so we know right away, we can see ourselves a right triangle. If I was to just draw that in here, right, we got our right triangle right there. We got our hypotenuse right here. Okay, so really, we want to know which one walked further. So in order to do that, we've got to figure out what our C is. So right away, we've got to write down our formula. A squared plus B squared is C squared. Okay, now looking at this, we know what B is down here. All right, oh, that was a bad B. We don't know what C is. I'm just going to squiggle that one out. We don't know what C is there, but you're saying, I also know what A is. But really, you do. Because it's a rectangle here, these sides are going to be equal. So if this side is 120, it means this side is also going to be 120. So we know that side A is going to be 120 meters. So when I fill it in, we're going to have 120 meters squared plus B is 300. 300 meters squared equals C squared. When I square 120, that's like saying 120 times 120. I get 14,400 meters squared. Plus, when I have 300 squared, I get 90,000 meters squared equals C squared. Now when I add them up together to finish the operation, I get 104,400 meters squared equals C squared. And last but not least, I need to find that side length. So when I square root both sides, my squares cancel out. And I'm left with 323 point, and got to go decimal and round to 1, meters equals C. So now I found out that this side here is 323.1 meters. Now, I've solved that, but I haven't finished the question. If I was to end here, I'd get it wrong. Because the question is saying to me, who walked farther? In order to find that, I've got to look at, okay, I know Michael went, this way, like this. So Michael, he walked 120 meters this way, and then across, he walked 300. So I have to add those together. So Michael walked for a total of 420 meters. Now Connor, on the other hand, he was kind of smart here. Connor decided rather than walking all the way around the field, I'll just walk right across it. And we know now, by walking across, Connor only ended up walking 323.1 meters. So who walked farther? That would be my friend Michael here, because when you look at both answers, 420 is far further, so we know that Michael walked further. So, last one here. How long is the ladder? So you can see my lovely drawing of a ladder here, leaning up against a wall that is 4 meters high, and the base of the ladder, which is here, is 2 meters away. So I want to know how tall this ladder is. So really, again, you can pause it here and then hit play when you're ready to watch. So guys, you can see this is really no different than what you've been doing the past couple weeks here. We got to look at it again, right in our formula, because we can see it's a right triangle. So a squared plus b squared equals c squared. We know our a squared and we know our b squared. We just don't know c. So a squared is 4 meters. We're going to fill in what we know. Plus 2 meters equals c squared. 4 squared is 4 times 4, which is 16 meters squared. Oop, that's not a g, that's a 6. Plus 2 meters times 2 meters is 4 meters squared equals c squared. When we add them together, we're going to get 20 meters squared. And all we have to do now is square root to find the side length. Well, when we square root both sides, we know that the squares cancel out, and we're left with 4.5 meters equals c. And the answer becomes 4.5 meters. That's it, guys. So this is how you're going to see your assignments go. It's just more interpreting the information in the problem-solving paragraph or from the picture, Make sure you're turning it into a Pythagorean theorem problem by using your a squared plus b squared is c squared, and making sure that it's asking for a side length, rooting it. If it's not asking for a side length, you can leave it as your square. But other than that, that's it for today. So good luck with your assignments, and I'll see you tomorrow.